So, good afternoon, everybody. Can you hear me clear?
Good afternoon, Chief.
Yes, Chief.
Good afternoon, Chief.
Yeah, good afternoon. So let us start. Last class we stopped here and this was explained how to break the chain. Since there was a bit disturbance last class, so if let me go through quickly go through it so that if you have any questions and you can ask me. So last class what we have seen, so we have seen the chain drive and the gear drive, and we have seen the arrangement. This was the gear arrangement. One of the, like Mitsubishi, they use this kind of, or Sulzer also, some ships, they use, some engine, they ship use this. The height is at the upper side, that camshaft. So we have seen the four-stroke engine, how the gear arrangement is. And then we have seen, we have completed the roller, how the roller arrangement, which engine uses the roller, that BMW is still using the roller, though now there is no push rod, but because of the push rod, they were using chain drive so that they can keep the camshaft at the upper side. So the push rod length was reduced. But still they are saying, according to them, the manufacturer, BMW, that still they are getting the benefit because idler is less idler, that is lighter. So there are benefits, that's why still they are using it. And then we have seen that chain drive where it is. We have seen also the advantage and a disadvantage of chain drive, but where it is placed for chain drive, it is at the end of the engine, or for up to 7 cylinder, it is end of the engine, and from 8 to 12, it is at the middle of the engine, so that the twist of the camshaft is less. And as well as the stretch will be, otherwise the twist, that is the torsion, will be high at the end. That is the reason it is kept at the middle. And then we have seen the arrangement of the link, and the link, this is the, we have the link plate, pin link, that is the outer plate. We have the inner plate, and we have seen the pin arrangement as well as the bush arrangement. Bush is interference fit with the inner plate, and pin is interference fit with the outer plate. And on the top of the bush, we have the roller. And there is a clearance provided between the outer surface of the bush and the inner surface of the roller, and pin surface and the inner surface of the bushing or the bush. And we have seen that we have completed that it will get elongated, and there is a limit how much it can elongate, because it will, how it gets elongated, because of the wear down of the pin will get worn out, pin, and between there will be wear down between the pin and inner surface of the bush, and then there will be a wear down between the pin and the bush, outside surface of the bush and the roller. And there will be another wear down, that will be this roller will be in contact with your sprocket. So sprocket and the roller. So because of that, it will get stretched. But this material, it is always, when it is loaded, it will be very high tense, means it will be trying to stretch it. But this material is made very strong so that it does not get stretched. So this inner link plate and the outer link plate can get stretched. One of the reason, if you, as I told you last class, that if you put your finger on the surface, you will see it is rough surface. That rough surface, it is made intentionally, that is called pinning. It means with the high velocity, small balls are hit on the surface, so that it gives us the compressive force, that is the strength is increased. It means the surface is always under compression. And as we know, compressive force means it will prevent the opening of the crack, whereas tensile force is opening of the crack. So that is the reason pinning is done. And then we have seen, this is, we have completed with how we tighten the chain for the correct tightness. We have checked this, and we have seen why the spring is provided, because the over tightening should not be happening. And then we need to check the timing also. How we check the timing? Timing is checked by pin gauge, that also we covered. That pin gauge, always the maker will tell which unit, that particular unit will be at TDC for checking this timing. And usually it is number 1 unit. It will be at TDC, and then we'll check the marking on the flywheel first, then the pin gauge with the F-frame and the uh, crank wave. There will be a marking, it has to match, and pin gauge will match the punch only if it is correct position. And then another pin gauge we have by which we check the camshaft position. And then we know the reading is, the timing is correct. If it does not match, it has to match for getting the correct timing. If it does not match, then we'll have to correct it. We'll see how we correct it also. And then we have the one gauge we have, that is the profile gauge for this sprocket. So we know there will be a clearance. How much will be the clearance as per the manual? It is usually 3.5. It depends upon the size of the sprocket. So, and the size of the engine. If the engine is large, your size also will be large because dimension will be large. So then accordingly, this clearance with the filler gauge, this is the profile gauge, we check and record it, and we compare with the manufacturer's reading, as well as we compare with the previous reading. If there is any wear down or it remains same, how much is the wear down rate? All we can calculate, and we know that engine is safe. So then we have the arrangement of the sprocket. So this sprocket is supported. This is for the your chain, and that this drive is for the governor and lubricator, as well as there will be a drive for the your distributor. It all comes from the camshaft drive, and this shaft has to be supported. Where it is supported, it is in the frame, and it is a roller bearing we have, and the oil is supplied. Forced lubrication is done from the main lube oil system. And we have, if we need to change the, we need to remove the chain, we'll have to, means the link, two link we are allowed to remove once it gets elongated, and we need to break it. And what is the factor of safety we keep? It's 25 factor of safety, which is very high, so that it does not fail, chain does not fail. This factor of safety is the maximum working load on the chain, and it will be equal to the tensile force, tensile strength of our chain. Chain will be subjected to the tensile force, and it will, what is the break at tensile force, what it breaks load, that load is checked in the laboratory. And then we divide it by 25, and that is the maximum working load it should carry. It means the allowances, safety margin is very, very high we kept. And in the chain drive, we also put we use for the first moment and the second moment. This I have not till now gone into details. So we put the mass, some masses, so that it can be balanced. We will see that, we'll go in details of that. And then because the chain will be under the cyclic loading. Why it is cyclic loading? Because chain, when it is getting engaged, that time load is coming very high. After that, when it is coming out, load is reducing. So there will be always a cyclic loading. When it is getting engaged, load is increasing. When it is coming out, load is reduced. That's why if it is a slack, chain is slack, then what will happen? This difference in load will be very high and chain will break. That's why the chain tension is very, very important. And as well as we'll have the opposite direction. When you're running, you'll be having the shock, apart from shock load, you'll be having the timing also problem for the astern direction, because it has to rotate and then get tight, and then only it will start, and it will change the timing for that. So the cyclic, another problem for the chain drive, we know that is the polygon effect. Polygon effect is nothing. It is nothing means it is what it is actually. We need to handle that. So it gives you a jerky effect, and it can break actually. Jerky effect means sudden load is coming and sudden load is reducing, and it gives a jerk. So this happens because of this velocity. Uh, this velocity, this is called cordial velocity. This will be maximum at this point because this distance is more. And this R, actually this distance we can calculate in terms of the angle and all. And means it's in terms of this R at this, what is the angle between these two? This we can calculate what is the velocity here. And this velocity will be higher because R is high. And next moment what will happen, this C will come here. So for let us see this one is showing it. This is B is here. Now next moment what will happen, B will shift here and C was here. Now C has come here. What had happened when it was here, that time it was smaller, the distance, and it is having an angular velocity, and this distance is R, which is more. So this will be V max and this will be V minimum. So this difference of these two velocity, it means when V minimum it is and it is coming to V max, from this situation to this situation, there has to be an acceleration. Otherwise, how will the velocity will increase? And next moment, again, this position will come to this position. Then what will happen? It has to decelerate. So because of that, you will be having a jerky motion, which you don't want because that can have adverse effect on the chain drive. So how we deal with that? In that case, we keep the number of link with the teeth, we keep 70 to 23 because if we see the speed, this is the cordial speed percentage variation and this is the number of teeth. So it will, if you plot a curve, it will be like this. It means as the number of teeth increasing, our jerky motion will reduce because the difference between minimum and maximum will reduce. And we found that by experiment, it will be 17 to 23 is the best we should have. Another thing, the center to center distance, because we'll have to see, we can increase, but we don't increase. Why? That number of teeth, because the moment you increase the number of teeth, your pitch will reduce, as well as it will become weaker, as well as cost will increase because more number of profile has to be machined. So all that's why we restrict to this. It helps us for all aspect. And center to center distance between the two sprocket, what we keep. So this is another sprocket. So this center to center distance, we keep the multiply of the pitch, the link. So multiply of the link. So what will happen? This polygon effect will reduce because this will move this way. This is also at the same time will move this way because it is multiplied by the our link. That is the way it is handled. We keep it like that. So the next is lubrication. Lubrication we have seen it is the spray lubrication and it is in both the direction because our engine is reversible engine. And the wear, due to the wear, it will stretch. And once it is stretched, we need to measure how much is the stretch. What is the allowable 1%. So what we did, we know number of, it will tell you manual that how many, from where to where, how many link you are measuring. So usually it is 10 link. Where we measure, it means you'll have to have access to this 10 link. It will be always, you will see on this free side. It means there will be a free, this side is for an example free and this side we are having a jockey wheel for the tensioning. So we'll be having like this. So this side will be measuring because this side will be, you'll get the longest side. So 10 link we measure and measured value we know and 10 multiplied by the our pitch. So we know how much is the original length and we can calculate the how much percentage it has increased. If it is 1%, then we'll have to means the number of link will have to reduce. 2 link we can reduce. It is allowed up to 2 link. And once you remove 2 link, you'll be removing from here, this side, because this side is accessible. So after that, what we'll do, this you'll have to slacken this, and then this side there will be 2 link you have shortened. From this side, you with the chain block you lift it, and 1 link you shift on the sprocket. So now both side will be having the 1. This side 1 is reduced, this side 1 is reduced. That's why always it is like you do that way, and then you check the tensioning, and after that you check the timing. If the timing is not proper, then you'll have to adjust it. So there is a adjustment for the timing. And if you see, this is a value for a particular BMW K90GF 10 link. Suppose measured is 1081.3 millimeter, and the 10 link original length is this. So we can calculate by this. Measured length minus the original length divided by, it means this original length we can calculate by the pitch. Pitch and number 10 link multiplied by the pitch, will get this value. And this value will be here, and divided by this value multiplied by 100, will get how much is the elongation. And if it is 1%, it means you cannot go beyond 1%. So you need to remove 2 link. It means after that, if it is getting elongated, stretched and elongated, you will have to change the chain. So after that, you cannot remove any other link. And this, this one, that 10 link, it is the same thing. You select so that such a space there where you can have the, we can have the access. As well as you turn it, you measure another set of 10 link, and then you can take an average. It means few section you'll have to take. Only one section will not give you, because there can be a chances that there is uneven wear down. In that case, how will you decide that the chain is elongated, full length is 1% or not? So that's why it is in section, you turn it and bring some other section to that free area, free length, and then you check the measurement and you can take an average. And then 3 section you take, or the 4 section, and then you take the average of it, and then you can calculate how much is the elongation. So now when you are another thing like tension, you have how do you check it? We have this side, we have suppose this is the chain, and this is the we'll have to rotate. It means when you are checking the tension, that time you'll have to rotate in this direction, so that this is under tension, this side is slack. And when you are measuring the length, that time also this side should be in tension, then you measure it, because the link should be in tension when you are measuring. That will give you the correct length. Because of on wear down, it will give you, it will under stretch, so it will give you the correct reading. So adjustment of the chain we have seen, and this is the way we check. We can push it transversely, and we can check. In that case, when you are checking this, you'll have, this has to be in slack condition. So this tension, you bring it here and then you push it. But when you are measuring, it is just opposite. It means this has to be under tension. But when you are checking this, that how much is the slackness, all slack has to be here. It means in that case, how will you do? This will rotate in this direction. And when you are checking the length, that time this should be in this direction, and then you make it under tension. And this is making under slack, and then you push it. So shortening of chain, we have seen this last class. What we do, we put a tool which we can tighten here. Once we tighten here, what will happen? This chain, there will be a clearance provided between the pin and the our push. Then we can break the chain. Otherwise, you will not be able to break because it is going to be under load. It means there is no load now because we have tightened this. And then we break it. How we break, that is we have seen. And how many we remove? We'll break this one, we'll break this one, and then the 1, 2, 3 we remove. Once we remove, then we put a this will be inner link, this is inner link, and we'll bring closer by tightening this, and then this hole will be on the our inner link, and this is on the inner link. We bring it close, it will be here. Once we tighten it, and this will come to here. Once it comes here, these two, we put a outer link. And then we join together. So this outer link, how it is, outer link is like this. So this is the outer link. One side it will be coming with the pin. This is the pin, this is the pin. So this will be the pin on this side, and this will be the pin on this side. And for an example, let me draw it other side. So this will be the pin. Yeah, Safanias, tell me. Safanias, tell me.
Okay, thank you. What is the purpose of removing three links? Why don't we just remove two links, one from inside, one from outside, and then just connect the inner link from right side to the outer link on the left side? Why do we need to remove both and punch twice?
That's why if you must check if you have the spare or not. Why it is? Because it is already used and it is come in set. It means what you are thinking that this pin you will be removing. This you don't want to remove, isn't it? So after that you pull it. This one come here. That means this one will come to this side. It means we break this. We don't break this. What will happen? This we can remove. This we have broken. This two link we remove. After that we make it closer. This hole comes here, and then you put the pin. That's what you are thinking, isn't it? Now let us see how the construction of the outer pin. Outer pin will be pin link will be, this is the outer pin link, and this pin is come with this. It means if you see your outer pin link, one side is with the plate. So this is the plate where this is the pin, this is the pin, and this is fixed with this. It is interference fit, it comes together with. And this side is, we have the soft head, this is the soft part. This is the soft part for the riveting. And your plate, this plate will be coming here. Understood? So you'll have to break both to remove this link. You cannot break one. If you break one, after that, which pin you will be using? Because you have already damaged the pin. Same pin should not be used. So what will happen? You'll have to break both. What if you break this? This also will come out. You have to come out because this comes with this. One side it is attached to. Other side is open where actually we put together, and then this will be interference fit. There is a tool, we'll see that, and then we rivet it. So this two pin And this comes in set because this is interference fit. When machining is done, all the link may not be having the exact same dimension because there are tolerances. So these always comes in pair, one set. So we'll have to use one set. Understood, Sophonius?
Okay, so this means it's because the pin is attached to the other side of the plate.
Not only that, once you have rivet means it was riveted here on this side. Why we don't use the same pin again? This was riveted here. So how did you rivet it? By hammering, for an example. Now we have grinded out. How will you use this pin? Understood? We have grounded this. Now this portion is not there.
Why don't we put another pin?
Another pin does not. It comes in this set because of the interference fit. It is machined exactly for this pin. This all has got marking. You should never mix up. Understood? As I told you, this machining will not be exactly the same for all. There will be some tolerance, but it is always come in the set. This outer link will come. This two part in set. One is the plate, only plate. Another plate with your pin. So that's the reason, one of the slide, it is written that the pin, once it is used, you should never reuse it because it is already damaged, this side. Even if you do little projection, it comes out and you do the riveting, but that will not be sufficient to hold that. So that's the reason it is 3 link is removed, then 1 new link you put. It means this link, what we are putting is new link. New spare link. So unless it is very emergency situation to make port, it's different. That time you will not run the engine at full load. That is emergency, but in normal condition, no. You'll have to use a new pin when you are assembling it. And for that, you need to break 2 outer link, 1 inner link to remove the 2 link, and then you one outer link, you new spare outer link you fit. Clear? Understood? What is the problem of reusing the same pin? Because interference fit also will lose, as well as this head that the rivet we have already damaged, we have grinded, otherwise you won't be able to take out the pin. So it is all the manufacturer will say it is clearly written, do not use the same pin. Once it is used, it will fail again. Clear, Sophonius?
Yes, yes, Chef.
So
I was thinking pin was coming separately.
No. It does not come separately. If you see your spare parts, it will be like this. One set it will come. One side. This we only will see now how we are fitting. Then you will realize that only one side we are actually putting the pin. It is there in your syllabus. Yeah, Lalisa, tell me. Lalisa, you raise your hand.
Yes, Chief, sorry.
Yeah, tell me.
When we are assembling this new pin,
Yeah,
one side is we need to make riveting.
yeah.
So how we can make riveting? Only by hammering or
Yeah, we'll see. Yeah, by hammering we can do, and by that is the way we do. We will see how we are assembling. You'll come to know. It is by hammering.
Okay.
So then we have actually last class we have seen how we break this is the breaking tool. That's why it is called chain breaker. So after that we pull it and then we assemble the outer link. Now, it means these two is the inner link. We pull it and then we assembled it. So now, if we see the timing, how do we check the TDC? We keep it number 1 unit, and after that, actually, once you assembled it, after that, the chain tension has to be corrected. That means chain tension you do, because when you are braking, you'll have to slack the chain to break it. After that, you tensioning is done. After that, you turn the 1 revolution of the uh, crankshaft. After that, you take the timing. So after that, it means once you rotate, it will be in a direction. Once you, because that clearance what we give, that we keep it for the astern direction, because astern is very little time we uh, run. So in that case, 1 turn, you complete turn you do. After that, you check the timing. Timing, what I explained, it is the exactly same way, that pin gauge. By using the pin gauge, you'll have to check the timing. And all the engine has got a punch mark for the pin gauge. And toolbox will be finding the pin gauge. And with the pin gauge also, you'll be checking the lubricator drive, as well as the your this distributor drive. Now we are now this also was covered also, that how often you do the inspection. Initially, so every 1,000 hours of the engine running we need to do. After that, once 8 to 10,000 hours, then annually you can do. After that, actually you do 3 monthly, then 8,000 or 6 to 8,000 hours. If it is working fine, then annually you can do, because then there is no problem as such. So the misalignment, if it is there, then the chain will get twisted, because if the center line it does not match, then what will happen when it is rotating, moving, that time chain will get twisted. So then that's why one of the checks we do, that chain should not be twisted. So otherwise chain stress will be high and chain can fail. So maximum wear we have already seen, that is the profile gauge we check. And then the removal of the chain, that is we remove the top cover, and then we for removal we'll have to break the chain. And then what we do with the chain block, 2 chain block we keep both side, and then one side we remove, and other side what we do, slowly drop into the we lift it and drop into the crankcase, and then from other side we lift it. So it will come, it will move down, and then it will come like this. And like I was telling, that if you remove 2 link, this will have to lift, and this sprocket, 1 pin, suppose we have removed from this side 2, so this pin will shift here. So then what will happen? This side and this side will be 1-1 equally, it will be shared. And this one, the details is there, how we remove, but it is, you need to maneuver it, like it is the same thing is written. When you are removing the chain, that time, suppose you want, you'll have to renew, or you'll have to, as per the survey requirement, you need to check the length, complete length of the chain. Then you'll have to remove it, because inside you cannot do. And if you are renewing that, on that time also, you'll have to remove the old chain. So in that case, you'll have to, when you are removing it, lifting with the chain block, to both sides you have a chain block support. And when you are removing it, you should be very, very careful. You'll have to maneuver with the hand, so that the sprocket should not get damaged. Sprocket might get damaged. And another thing, when we are shifting this, that time our camshaft, this sprocket, we can lock it. So there is a hole in here, there is a pin. With that pin, we put that pin so that this sprocket will not turn. So we can lift it, and there is chances when you are lifting it can turn. So that's why it is been done. Now let us see how it is removed. How do you maneuver? It means when you are removing top copper, you remove, then convenient point, you break the chain, and then sealing, wire sealing you put, and wire sealing you'll have to put long wire sealing. It means you'll have to adjust such a way so that it can be reached, wire sealing can reach in the crankcase, but your hook should not enter because it will damage then the sprocket. So we break after that. The braking we have seen, this is one of the braking tools, and there are another tools also. Both are doing the same here also. It means we grinded it and then we turn it. When you turn it, this will move downward and it will push the pin out of the this link plate. And other side, it will come out together with the pin and the link. And this is the chain replacement. In the chain replacement, what do you have? The two chain block you'll have to have, and then you'll have to maneuver such a way so that jockey wheel and all should not get damaged. It means you remove from the sprocket because it is free now. You can always with the hand you can remove, and somebody can lift it with the chain block. So complete chain can be removed. So after that tensioning, it means the when you draw two ends together, that it is fully slack, it should be. And then you can insert a new link, that is the when you are assembling. So outer link plate, so it will drive the shoulder. Let us see how actually it's assembled of the chain. So this is one way. This is also last time I have covered the one way we can do. So this pin, it means this outer link is with the pin, and this is the outer link, another outer link which does not have the pin. That is interference fit here. This is already interference fit. So by this we can put back this link so that it will go inside, because you are hammering with the, this is a punch, we can hammer it and put it. After that with the hammer ball, this side, that the ball pin, you can rivet it. So this is one way, but another way we can have, like another way we can break it like this, and after that you tighten more, it is coming closer. That previous tool and this is same. So this is with the straw, and we can bring it closer, and that time slack, it has to be slacken so that it can move that much. And then we chisel it off the pinned over dumple, that is the rivet, and then we remove the link. So three link, just one sec. What happened? So this sprocket with this also, it is the same way we do. Both are same actually. If you see the principle how you actually pulling together, so that this will be offloaded and we can break the pin, and then link, outer link will be removed, and then we tighten again, and then we put a new link. And this like the screw has to be turned. There are two pin we are removing. In that case, what will happen? One pin 60 degree you turn, another pin 60 degree, and then evenly it will be removed, because it has to come out evenly. So this is evenly we can remove. This one I had explained last time, and there was a doubt of some of you, and when I drawn it already, so you have understood how it breaks. And when it is pushing the pin both simultaneously, then this outer link will come out, pin will come out with this outer link. And the top plate, this is the this side pin, and there is marking always. So which side is with the pin. So then this will remain there, and then after that we can remove, because pin has already come out from this plate. Now how do you assemble? This is the assembly. Now what happened? We have the tool. This is the tool on this side we keep, and other side this is the tool. This is the pin. You can see this is the outer link with the pin. with interference fit. So we put this on this side. And this tool, if you see, it can, this is the bolt you have here, this goes here. And another one, this one goes here. And this pin, once it enters, because there is a clearance between this is the bush and the pin. Pin will go inside, there is no problem. So once we put this, it means this assembly will push by this with this. First, what we do, we don't put this plate, this side plate. This side also there will be one outer link which will be fitted on the pin, but we don't put that. First, what we do, we fit this one. Once we fit, it means this side you have this piece and this side you have this part of the tool, and this is threaded hole. So this is having a thread, this bolt. And then once you assemble, what will happen? This thread, it will go, this two bolts will go into this thread, and then it will come closer as you are tightening. And this outer link will fit into this. It means first we fit into this with this. So this will push inside this pin, and then we have the plate, outer plate will come to a position here like this, in this. But other side there will be, it means pin will come out, and this hole diameter is more than the pin diameter. So there will not be any interference. And this tool comes exactly that it should be aligned, and it is aligned such a way so that it will come exactly, the pin will come out with this once you are tightening. And if you see your link, your bolt will move on the side. If you see this, this one, can you see the bolt where it is moving? Other side also will take the same position. Now we have put this inside the bush. Once it is inside the bush, and we, with the help of these two tools we have put, now this pin has come out, projected out from this side, that will go inside this. And this diameter is more than this diameter. After that, you can remove this. After that, once you remove, then you put the, now you will be putting the, your outer plate on this side. And once you put the outer plate in between, again you tighten it, then what will happen? The outer plate hole, this pin will enter into the outer plate hole. And because it is interference fit, and this is will be fitting by this tool, and in both the hole pin will go enter into the outer plate, that is the link plate, outer link plate, and then the, it will the pin head, this is, will come out from the outer plate. And once it's come out from the outer plate, after that we can do by hammering, we can do the our riveting. We do that because these are, this is kept soft part. It means the pin is very hard, but we know that differential cooling we can do on the same piece. So this side we slowly cool, so it is softer. This we do the cooling is faster, and surface hardening is done. It is very hard material, it should not be deformed. And then we do the riveting. Is it clear? Have you understood this? How we assemble? So we have one side outer link, two pin, another side exactly one link will be there with the hole. So first we push it in place. After that we put this other side link plate, outer link plate, we put it, and with the same tool we fit it interference fit. And then once it is interference fit, after that we do the riveting for the soft end. So this is the way it is assembled. Once it is assembled, after that we tighten the chain. Chain tensioning is done. We have seen how it is done. After that, we turn it for one revolution and ahead direction. After that, we check the timing. And if there is a timing is not correct, then timing has to be adjusted. So how the timing, yeah, Tasfan, tell me.
Sir, this tool can make riveting also, or after putting the pins, the riveting is by other system.
This one will not make riveting because this hole is more than this hole. So, and clumping is this with this. So this hole will be in way of this pin. So pin has to be flattened, isn't it, for the rivet? So that will not do this. So that is done by the hammering. So because this dimension will not change, it will remain same, which is higher than this. The internal diameter is more than the outer diameter of the pin. So this is, you can see it is a straight line. It is same diameter because it should not get damaged when you are putting. So it is kept like that. Understood, Teka?
Yes, sir. Yes, it's now clear.
Otherwise, yeah, it will not become flat. Then this diameter has to be smaller, or there has to be a curved head like that, but which is not there. Yeah. So,
Sir, the interference fit is between the plate and the pin, and also between the bush inside. I mean, this tool is
say again.
for the interference fit.
Yeah.
The interference fit is between the pin and the plate, yeah?
Between the plate and the pin. It is not, this bush is not interference fit, but there are very small clearances. So that's why this tool, it has to be aligned exactly so that it goes inside. So there is no damage to that. Yeah, Sophonias, tell me.
Thank you.
Yeah.
Okay, thank you, Chief.
Yeah.
So when we are always removing links, we have to remove two. But our measurement, if it tells us only one link, then we can manage this with the tensioner.
So one link, see, there are certain factors. One is the elongation, maximum 1%. Once it is reaches to 1%, we can remove two link. And by tensioner, in between, till you remove pin, there is extension, elongation of the chain. That we adjust by our tensioner. But once it reaches to the one, that is 1%, then we can change to link. Till then, we adjust with the tensioner.
Okay.
Now we have this is the one of the arrangement. Unsupported side has to be supported. That's why there is guide, and there will be rubber lining. Never remove that rubber lining, because that lining is provided for the shock absorber. Because chain can vibrate. It can vibrate because of itself. It can vibrate because of the engine operation also. Suppose the engine vibration is high, chain also will vibrate. So, and these are the, in this diagram, these are the unsupported length, long length. That's why these guides are provided. These guides are secured with the casing, that is the A-frame. And then it will be in place, and inside there will be lining. That is the rubber lining, so that it absorbs the vibration. So if there is a vibration, it can fail. Also, it will be having a cyclic loading. So, and the sprocket, how it is, for an example, this the crankshaft sprocket, it is in two halves. We have seen that thing during the crankshaft. So it will be on the two half. This is our crankshaft for an example, and we have two half, we have the sprocket. So it will be in two halves. So we can, if the sprocket is damaged, we can remove the sprocket and again fit it. We don't have to dismantle the crankshaft. And we need to have minimum one intermediate jockey wheel, which is center point is, we have seen the reason. This is movable. So it can move this direction, this direction. We can have number of jockey wheel, more than one. But one of them has to arrange this for tightening the chain. Otherwise, we won't be able to tighten, put the tension on the chain. And also this takes the cylinder lubricator, aesthetic distributor. These all from the auxiliary chain. We have seen the one diagram, the drive. There are auxiliary chain which is driving this cylinder lubricator, starting and distributor, because they are also driven by the camshaft. And camshaft is driven by our crankshaft. Now there is something called the first moment and the second moment. We actually balance up to second moment. We don't go beyond that, because as the moment increases, that third moment, fourth moment, it become reduced actually. So up to second moment.